In this video, we are going to find the vertex, focus, directrix and the latus rectum of a parabola. Here is an equation of a parabola in general form. The first thing to do is, move -8y, and the constant -20 to the right. By adding +8y, and +20 to both sides, we can now cancel the following. We now have x squared, minus 4x, equal to 8y plus 20, next is we complete the perfect square trinomial by adding a third term. So, how do we calculate for the third term? To get the value of the third term, we divide the middle term numerical coefficient by 2, and then square it. As shown, we now have a value of 4. Since we added 4 to the left, we also add 4 to the right. We now have x squared minus 4x plus 4 equal to 8y plus 24. Now let's create a parenthesis with the power of 2. Get the half of the first term and second term as shown, so it's x and -2, and put it inside the parenthesis. We need to remove the numerical coefficient 8, accompanied by y, so we have to factor it out. This is the standard form of a parabola. As you can see, there is 4p in the middle. So what do we do with this 4p? We equate it to the value above, which is 8. Now, we only need the p, so we have to remove 4 from it. To remove 4, we divide both sides with 4 as shown. Now 4 will be cancelled, and divide 8 by 4. We now have a p-value, equal to 2. We can now look for the coordinate of the vertex, which is represented by the h and k, and according to our last equation, h is 2, and k is -3. We now have the vertex coordinate, 2, -3. Maybe you can notice the sign, so why does -2 became +2 or +3, became -3? Let's work with y plus 3, as an example. What we do is, we equate it to 0 first. Now we add -3 to both sides as shown. We can now cancel 3. As you can see, y is now equal to -3. Let us find the focus now. With the following format, you just substitute with the above values. So it's, h is 2, k is -3, plus p, which is equal to 2. The focus point is set, at coordinate 2, -1. Next is the directrix, and this time, it's subtraction, with almost the format as the focus. With the values from above, we have, h is 2, k is -3, minus p, which is 2. The directrix is set, at coordinate 2, -5. We can now graph the values we have just got. With these grid lines, we can now start with the vertex. Our vertex, at 2, -3 is now set with a yellow dot. The focus coordinate, is now also marked with a yellow dot. Since the focus is always inside the parabola, we now at least see how it looks like, and it opens upward. We are not yet sure with the width of the parabola, but let us work on that later. The directrix is a line, and we have marked a dot on its coordinate. Now we have drawn a line from the coordinate of the directrix. Now, we can call the distance between the vertex and the focus as a. It's also the same distance with the vertex and the directrix, so that would be 2 times a. The distance between the focus and the directrix is 2 times a. The latus rectum is a line stretching from both sides of the parabola, passing through the focus. The distance between the focus and one side of the parabola is 2 times a, as shown in blue line. So, the length of the latus rectum, from side to side is 2 times 2, times a. Now that we just got the coordinates of the latus rectum, we can now recreate the parabola passing through the vertex, and through its latus rectum endpoints. This is how the parabola looks like, after counting the latus rectum units. This is another way of finding the coordinates of the latus rectum. In this example, the line of latus rectum is at y, equal to -1, now, to calculate for the coordinates of the latus rectum, we will be using these two equations. First, we substitute y, with the value of y above which is -1. Distribute 8 to the right, and we got -8 plus 20. Since x is squared, let us make it a perfect square trinomial, by adding the third term. To find the third term, we divide the middle term numerical coefficient by 2, and square it as shown, so the third term is 4. Since we added 4 to the left, we also add 4 to the right. Now, create a squared parenthesis, equated to 16. X minus 2, is actually the half of x squared, and -4. The next thing to do is, to remove the power 2, so we get the root of both sides, which will equate it to positive and negative. This will cancel the power 2. We now have x minus 2, equal to positive -4. We can now move -2 to the right, by adding positive 2, to both sides. Now -2 is cancelled, and x remains. X is now equated to 2 plus -4, we can actually separate the plus and minus process. We now have two values for the x of 1 is 6, and x of 2 is -2. We can now form the endpoint coordinates of the latus rectum with this format. Just substitute x and y with the above values. The endpoint coordinates of the latus rectum are 6, -1, and -2, -1.